And now I'd like to invite the next presenter, Mariia from TRAQC. Alrighty. So Mariia is going to join me on the stage. I hope I pronounced the company name right. Is it TRAQC? I think she'll correct me the moment she comes on the stage. And she's going to be telling us about inline at speed quality assurance for printed electronics. And welcome on stage. Nice to see you again.
Nice to see you, Kasha, and everybody. We are just TRAQC. We have QC at the end, but we are just TRAQC.
Yeah, it's good. Yeah, good luck.
Thank you. So thank you everyone for attention. Good afternoon or good evening. So at TRAQC, we are developing real-time AI-driven automated inspection solution for printed electronics. TRAQC, just I will start with the presentation of the company and then how it happened and what we're actually doing. So TRAQC is based in Montreal, Canada, where we are very well located for both academic activities and industry research as well on improving printed electronics materials and industrial processes. So TRAQC was co-founded by myself and Benjamin during our graduate school. So I have done my PhD when I was developing quality control solution for printed electronics. And how it all started, when I was starting my PhD, I was visiting facilities at Institute for Graphic Communication and Printability in Montreal, and I was really fascinated by the way of this production. This is how I find out that the process is continuous, very high volume, but the quality assurance is mostly always done using probe method as here Ben is doing during validation of the conductivity after printing. So it's all done outside of the production line, which produce huge waste of the materials. And at that time, we were starting figuring out what other methods existed. And based on our knowledge, today the most known system starts with probe inspection, as we just saw in the video, which is always done outside of the production line and creates a lot of waste. And it can only justify the conductivity of the materials. When we are talking about camera system, which has been broadly used in graphic printing, they can keep up with the production speeds or can be installed in the high volume production roll-to-roll presses. However, it cannot just say anything about the functionality. It can just inspect the surface. And then recently we find out the eddy current technique is coming to the printed electronics manufacturers as well. However, based on what we've heard, this technique is not keeping up very well with the speed of the production, and it requires some area of the inks additionally printed to investigate the functionality of the materials. And then at TRAQC, like we starting with academic research and now trying to commercialize this idea, we find out that our solution can keep up with the speed about 50 meters per minute and even above or below. And it allows for high precision in line measurements, and we can do functionality of materials as well as geometrical verification can be done in line. So how we do it? The idea was inspired by graphic printing, where there's always quality control structure printed next to the main product, and they show the quality of the colors being printed. In our case, we propose to print the quality control structure next to the main printed device and investigate it with our special light. So the idea of scientific research, you can see article written, the title below, was to show that actually the functionality which we can detect with our light is the same as it can be done with conventionally commonly used techniques. So we printed a device and next to it a quality control structure, and we wanted to identify if we vary conductivity, what's going to happen. So this is just a strategy which we were using. And for doing that, we printed the structure. Here you can see their schematic illustration. So we printed a quality control structure. It's written here VPP. It's special title of the quality control structure, which we investigated with high frequency terahertz light. And on the side, we also did inspection with 4-point probe method, atomic force microscopy to investigate the surface, and multimeter with with micro probes to make sure that we can do investigation on both sides, on the device